The magnetic field associated with the light wave is given at the origin by B is equal to B naught sine 6.28 into 10 to the power 7 Ct. If this light falls on a silver plate having work function 4.7 electron volt, what will be the maximum kinetic energy of the photoelectrons? So, the equation given, B is equal to amplitude of that varying magnetic field is B naught sine 6.28 into 10 to the power 7 Ct. So, this is omega into Ct. So, omega is this. So, if I write the reference equation, it is B naught sine omega t. So, when I refer, omega is 6.28 into 10 to the power 7, c is the speed of light. So, that is 6.28 into 10 to the power 7 into 3 into 10 to the power 8 is omega, and omega is 2 pi f is equal to 6.28 into 3 into 10 to the power 15. So, 2 pi and 6.28 cancel. So, the frequency is 10 to the power 15 hertz. Okay, 10 to the power 15 hertz. Now, what they have asked is the maximum kinetic energy of the photoelectrons. So, this is a incident frequency. Work function is given. So, E is equal to phi naught plus kinetic energy. E is equal to H into F that we have calculated, and work function is 4.7 electron volt, and this is kinetic energy. So, H by E into F, if you give, that will be giving you energy in terms of electron volts. I will tell you, E is equal to H into frequency, that will give you energy in joules. So, suppose if you do take the ratio of H by E and multiply it with frequency, that will give the value in electron volts. Now, H by E has got a fixed value, that is 4.12 into 10 to the power minus 14 into F, that will give you the answer in electron volts, which I am going to substitute here. So, that is 4.7 electron volt plus kinetic energy. So, this is 4.12 into 10 to the power minus 14 into 3 into 10 to the power 15 is equal to 4.7 plus kinetic energy. Now that will be 4.12 into 3. That will turn out nearly how much we have to calculate. Just now, that is kinetic energy now. So, 4.4 into 3 is 12. This is nearly 4.1215, or I will just roughly take it as 36. 3 into 4.12 is 12.36 into 10 is what I am getting, into 10 is what I am getting. This is 10 to the power minus 15 itself. So, that is done now, 10 to the power 0. So, that is 4.7 plus kinetic energy. So, 12.36 minus 4.7 is the kinetic energy. That will come roughly as 7.72 electron volt is the kinetic energy of the emitted electrons, which seems to be option D.